Hi, I'm Clint Rapier, System Engineer at Lower Valley Energy. Today, I'd like to answer the questions, what is electrical demand, why is it important, and why do some rate classes bill for it? I'll do that by showing you the difference between electrical consumption and demand, and then we'll look at a few different examples to show you why it's important. Most of us are familiar with electrical consumption or usage, which is measured in kilowatt hours and has appeared on electric bills all along. It is found by taking the rate of our usage or power in kilowatts multiplied by the time it is used. Kilowatts times hours equals kilowatt hours. We've probably all seen that one before. Demand, however, is the peak usage during any period of time, whenever the consumer's load demands the greatest amount of power. Because the electrical grid needs to be large enough and have sufficient generation available in that moment, electrical demand dictates how large the entire electrical grid needs to be to give consumers all the power they need whenever it is needed. Now that you have an idea of what electrical demand is, let's look at three different consumers and how they each use electricity differently to understand their electrical demands. Consumer A has a load of only 10 kilowatts and it runs continuously both day and night. We calculate their usage as 10 kilowatts times 24 hours a day times 30 days in this month, so their bill shows 7,200 kilowatt hours for the month. The most power they use at any one time is 10 kilowatts, so that's their demand. Since this load is small, the size of the wire and transformer feeding that service can also be relatively small, and the cost to install and maintain are fairly low. Consumer B has a larger load of 20 kilowatts, but only consumes electricity for 12 hours a day. Using the same method as before, we calculate their electrical consumption as 20 kilowatts times 12 hours each day and 30 days in this month. They use 7,200 kilowatt hours, just like Consumer A. But wait, their demand is twice as high, 20 kilowatts instead of 10 kilowatts, and thus the transformer and line feeding their service must be sized larger at a greater cost to install and maintain. Consumers A and B consume the same kilowatt hours, but their demand was different. So are these consumers equal and should be billed the same? Let's look at one more example, Consumer C. They have a large load of 120 kilowatts, but it only runs 2 hours a day. That's 120 kilowatts times 2 hours a day times 30 days. Just as before, they use the same 7,200 kilowatt hours a month, just like Consumer A and B did. But their demand is a whopping 12 times larger than Consumer A. That means the equipment they need to power their service is even larger and more expensive to build and maintain. Yet if all three consumers are paying only for the kilowatt hours they use, they all pay the same amount. So is this fair? Not really. That's why certain classes of ratepayers pay a demand charge to fairly recover the greater costs for the much larger system required to support the demand of how they use electricity. And when I say a much larger system, that impact is not only the one electrical service and its associated transformer. Multiply that by hundreds or thousands of consumers, and that impact means larger distribution lines all the way back to the substation, more and bigger substations, bigger transmission lines, and bigger generation adequate for the demand from all the consumers anytime that they may need it. Thus, rates which fairly allocate the cost of electrical demand are important both to us as the co-op and to each of our consumers, since electrical demand affects the co-op's cost to build and maintain the grid, assuring it works for each of us, supplying all the electricity we need whenever we need it. Thanks for watching.